In the first statement, the question said that the gravitational potential difference between the surface of the Earth A to 10 meters above the ground at point B, the potential difference is 4 joules per kilogram. So let's say the potential difference is between A, B is 4 joules per kilogram. Okay. Now, assuming the gravitational field is uniform, what is the meaning of uniform? Uniform means you have a constant field lines here that is parallel and equal distance. Okay. So what does that mean? That means, okay, let's say this is the surface of the Earth. Above the surface of the Earth, about 1000 meter, all the points within this region, they all have constant G with magnitude of 9.81 newtons per kilogram. That means if you put 1 kilogram at this point, 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 all of them will experience force of 9.81 newton. Okay, this is different from the non-uniform gravitational field strength that you have learned previously, right? So imagine this is the Earth. Okay, let's say this is the non-uniform gravitational field strength. So I said that the G here is larger, G1 and G2. Which one is larger, G? Obviously G1 is larger. G1 is larger. If you put 1 kg here, obviously you will experience larger force than if you place at G2, right? Because the G2 is weaker. Alright, so the meaning of uniform G means that you experiences the same force everywhere due to the same strength, same magnitude of strength in this region. Now the question asks, what is the work done in moving a mass from surface of the Earth at A to C, which is 5 meters above the ground? Okay, so in this case, we know that the potential difference between A and B, which is 10 meters above, is 4 joules per kilogram. What about the potential difference from A to C? Okay, what is the potential difference between A to C? Okay, is it 2 joules per kilogram, just half of it? Yes, it's just 2 joules per kilogram. Why so? We can just analyze normally because we can treat the ground here as 0. Okay, we treat the ground as GPE equals to 0. We treat as this 10 meter, the GPE is 4 joules. Alright, let's say this mass is 1 kilogram. So 10 meter, the GPE is 4 joules. 5 meter, the GPE definitely only 2 joules, right? Why we can just assume like that? I thought the GPE is 0 at infinity. Yes, it's true, but that one is only applicable for the non-uniform gravitational field. Remember the non-uniform gravitational field? We treat the infinity as 0. We treat the U at infinity or the GPE at infinity equal to 0. Okay, so and the rest all will be vary with 1 over R. See, remember GPE is equals to negative G mm over R. Actually, is inversely proportional to R, you know. But this is only true for non-uniform G. Okay. In fact, GPE also equals to mgh. And for this one, negative GMM over R, we take GPE at infinity equals to 0. For uniform field, we can safely say that GPE equals to mgh. Okay, and actually is proportional to the h, which is the distance from the surface of the Earth. This is for uniform G. Okay, when we say the GPE at the ground, okay, at the ground as 0. Okay, I hope you can distinguish between them. Okay, actually 0 is just a convenient point that we use to calculate things that we want to count, right? So in this case, no matter we use infinity as 0 or surface of the Earth as 0, it depends on the situation. Okay, well, most of the gravitational field question, they are dealing with non-uniform G. Okay, so in this case, we can treat infinity as 0 and the GPE for all the other points to be negative. Then we use this convention for the entire questions, it will be the same. You will get the same answer. Okay, so please remember this technique. If use uniform G, you can just use mgh because it happens only near the surface of the Earth, which is a special case of the law of gravitation in this topic. Come back to this question. So what is the work done? Okay, so what is the work done? Work done from A to C. So work done is mass times change of potential from A to C. The mass is 2 kg. The change of potential is 2 joules per kilogram, right? So the answer is 4 joules, D.